Hello and welcome to Coffee and Control, the podcast where I find fascinating people from within the world of control and convince them to answer all of my questions. I'm your host, Lucy Hodgins, and my guest today is the technical content creator at MathWorks. So most people will probably know this month's guest from his fabulous YouTube videos, which have helped many cohorts of control students pass their exams. So I was put in contact with him by a very lovely MathWorks employee named George, and we arranged to meet up at the Conference of Decision and Control back in December. It ended up being such a great conversation. This is kind of a different episode to what I've made before, in that it's very much just a discussion between me and this guest with minimal editing, but I hope you enjoy it. So, get ready to hear all about the role of control engineers in industry, including differences from working in academia, common misconceptions, advice for current students, how to best prepare students for industry work, plus some insights into his fantastic YouTube channel with my guest this month. It's Brian Douglas!
My name is Brian Douglas, and I work at MathWorks in the technical product marketing group. My background is in controls, spacecraft controls, mostly a little bit of aircraft controls. And what I do mostly now is get people excited to learn controls, to motivate them to stay along that path, to share with people how exciting I think the field is. And so most of my stuff is kind of on the education side, but I tend to think of it more of outreach and just getting students, getting professionals excited about the field.
So, I guess I want to start with a general introduction of how you got interested in control and your overall career trajectory. I know you've talked about this a bit with Alberto on the Control podcast, but just for anyone who hasn't listened to that.
Yeah, so my introduction to controls was completely unplanned. As a young student, I really liked aerodynamics, and I wanted to build ultralight aircraft and slow flying aircraft, and that's what I thought I was going to do, is be an aerodynamicist. And I went to Embry-Riddle Aeronautical University specifically for that reason, and got into aerospace control. And it just happened I wanted to get a job at Boeing because it's an aircraft company. The Boeing that showed up for the career fair was on the space side of things. And I got the internship just generic, and they asked me what I enjoyed, and I said, actually, I just took differential equations, and that was my favorite class because it felt, it was the first math class I took that felt kind of practical. And then they just stuck me in a controls group for my internship, and I had no idea what it was. In fact, I remember specifically thinking it was going to be like operating the satellite. It's like, oh, controls, right? And I spent 8 months there and got to talk with a lot of really smart, really enthusiastic folks in the field. And then I left there and I said, that's what I'm interested in. One, there's a job waiting for me, which is always a plus. But it turns out I think I'm just in general a curious person. And if I had been placed in any group, I honestly feel like that's the path I would have taken. This just happened to be the first thing that was presented to me at the time when I had to make a decision.
Okay, so you kind of started at Boeing and that's how you got interested in control. Where has your career taken you since then?
Yeah, well, I was in a line of sight group for a spacecraft, and we were spent a few years as just one of many control engineers working on this problem where light comes into a telescope and bounces around a bunch of mirrors, and you're just trying to move fast steering mirrors to correct the light to take out jitter and things like that. And loved it. And then I thought, I want to do something smaller. Boeing had just started their CubeSat program. And I was like, I want to do that. And then I got hired to work on the control system for CubeSat. But then I was the only one. I was the only controls engineer. And I knew nothing, it turned out. And the first couple projects sort of failed miserably with the control system, and eventually learned some, but spent 3-4 years doing controls for CubeSats, and then ended up moving up to Washington State. This was down in California. Moved up to Washington State in the United States and worked for 1 year on aircraft. Wasn't my favorite, so I left Boeing and joined a small space startup where I was, once again, one of the first control engineer on a spacecraft. But then we ended up growing that team. And my role turned into more of a systems engineer and then leading and directing the systems engineering team. And during that time, I was making YouTube videos on the side, and that just sort of took on a life of its own. And so, again, unplanned for the most part. But now, like I said at the beginning, mostly what I do is YouTube videos, outreach, and things of that nature.
Yeah, so as you kind of mentioned, you've spent a fair amount of time working as a control system engineer in industry. I guess I'd like to start with an overview of like what types of things a control engineer working in industry might be doing, what might a typical day look like.
One of the things that confused me when I was a student, I think, is that controls was control theory. My first class was a control theory class. My second class was a control theory class. I learned Laplace transforms and, transfer functions and state space and things like that. In industry, all of my jobs have been control engineering jobs. And a control engineer is responsible for, in some way, for everything that is involved in getting the system to do what you want it to do, that closed loop control. And so the vast majority of my time has always been in modeling the system, testing sensors and actuators, thinking about how information gets through the system to my control algorithm, thinking about how clean the data is and filtering it and writing tests to check if there's faults and then figuring out how to respond to those faults. And as well as control theory, actually doing the control algorithms and improving robustness and all of that kind of stuff. But that was mostly a really small part of the overall control engineering job. And that job then evolves as the project evolves over the life cycle. So at the beginning, you're thinking about formulating this concept, taking this concept of we need to accomplish this high level objective. What does that look like? Is it a spacecraft that does this? Is it an aircraft? Is it a vehicle on the ground? How do I accomplish that? And then you just start, working with other folks at the exact same time to kind of make sense of this really nebulous idea. And as a control engineer, you're bringing in your expertise to help shape that idea in a way that's going to make control possible or make the requirements simpler to meet. And then that evolves into, more detailed designs. And then that evolves into getting hardware in and testing hardware. And then that evolves into taking your hardware and combining it with everybody else's. And then that evolves into shipping whatever it is, whatever product, and then using it out in the field. And so the role of the control engineer evolves through that whole process. But again, it was the thing that shocked me the most was how, in my job, how little control theory there was as opposed to just the overall control engineering problem.
So you gave a webinar recently on misconceptions you had about control engineering. So I guess that's one of the misconceptions or a misconception that you had. So yeah, could you give kind of a general overview of what the misconceptions were that you talked about in the webinar?
So it turns out that they're all related to that exact one. Control theory, you're thinking, I need to design a controller. Well, in order to design a controller, often we need to have a model of the system. And wow, that's not straightforward in a lot of systems. And you spend a lot of time doing that. And it's like, this isn't what I was expecting to do. Another thing is when you're doing your control theory problems, at least I've tended to narrow-mindedly think of just the control aspect. And it's like, how do I improve this control system? How do I improve rise time and settling time and reduce the errors and things like that. And I always thought I need to, build the best thing I can possibly build from a controls perspective. And then you get to industry and it's like, well, controls is it's a part of the whole. It's interdisciplinary and you give and take with other people. And the better you make your system, sometimes that makes other systems harder in terms of the size of the actuators you need, the speed of the sensors, the speed of the compute power, and things like that. And then another misconception was just how interconnected all of these disciplines are. Mechanical engineering, electrical, software, controls, systems engineering. And sort of how little I thought about that as a student, especially after I had my internship and I knew I wanted to be a control engineer. It was like, I'm going to focus on theory and then I'll get to the industry and it's going to be great. And so there's misconceptions associated with exactly what you'd be doing. Another misconception is, I suppose, around the tools that you use. I don't know if this one's terribly important to talk about here, but I thought, coding my algorithm, because again, when you're thinking of control theory and your control algorithm specifically, you're thinking about, I need to code this up so I can give data into it. It can churn on that data and then it can give me a response. And so I tend to think of the tools associated with control engineering as like programming languages. And then when you get to industry on these large projects that I've worked on, and model-based design is so prevalent, and you're working with these multidisciplinary teams, and all of a sudden just being able to code your algorithms isn't enough. You need to be able to, deploy them onto embedded systems. You need to be able to interface with the rest of flight software. You need to be able to guarantee that it's meeting the requirements and all of that sort of stuff. And so it's a larger field than what I had originally thought. And because of that, it's so much more interesting in that regard, because there's a vast number of problems that you get to be involved in as a control engineer. And I didn't really have an appreciation of that as a student.
So you talked about the kind of interconnectedness of control design with like the rest of the system, other parts of the system. Are there any examples you can think of where something that initially seemed to be a control issue actually turned out to be related to some other part of the system?
Well, I'm going to interpret a control issue to mean something that causes your control loop to not behave the way that you want it to behave. In which case, anything that contributes to that is a control issue. And that happens all the time. Again, my background's in aerospace and satellites. And one of the things, if you don't work on spacecraft, that might not be intuitive to you is how small disturbance forces and torques are in space. And so small things like gravity gradients, where the farther away you get from like the Earth, the gravity gets weaker. And that gradient means that satellites that are like long and thin, gravity acts at different forces on different parts of the spacecraft, and that causes an ever so slightly small torque that rotates the spacecraft. It seems minuscule, but it adds up in space. And another thing is magnetic fields, which electric currents can create. And so if you have a solar array that's pointed towards the sun, it's generating power. That current is then traveling through some circuit board that's in some amount of a circle, and it creates a loop. You have now created a magnetic field that interacts with the Earth's magnetic field and causes a small torque that now you have to take out with the control system. Or you might be measuring the magnetic field with a magnetometer that you want to use for state estimation. Every time the satellite goes from eclipse and back into sun, and that magnetic field, turns on from the charging, it messes up your sensor. And you think, well, how am I going to deal with that? And so every decision in some way interacts and interferes with the control system, but it works both ways. I have sat down and I've designed a fantastic closed loop control for pointing a satellite, and I said, all I need is my control loop to run at 100 hertz, and it's going to be great. And I designed it, and it looks great on my computer. And I went and talked to the software engineer, and he said, there's no way. There's no way you're going to be able to run this at 100 hertz. You are sharing this processor with 1,000 other things that we need to do. And, you get 20 hertz. Go back and figure it out. And so it's hard not to be impacted by other groups, and it's hard not to impact them, which is the whole point of this design process, where you're talking with people and trying to work through all of these types of problems. But in the end, anything that keeps you from controlling your system is a control problem, even if it's not your responsibility to solve it.
This concept of the interconnectedness of control with all the other components of a design links very closely to the discussion I had last episode with Gioele Zardini. There we discussed his co-design framework, which is a super cool concept and formalises this interconnectedness mathematically, enabling it to be applied to a bunch of cool areas. I've left links to that interview in the description if you would like to check it out. Do you have any advice to students on how to become fluent in kind of other areas of engineering that might be useful throughout their career?
So, that might be useful. In some way, depending on what program you're on, everything is useful, and you can't learn everything. And so I guess my advice is to solve problems, because that's how you get exposed to things that you didn't even realize was going to be an issue. A lot of people, we these days we talk about project-based learning, and it's like low-cost hardware and software and stuff like that. That's a great way to do that. You can do it in any way. You could do it completely in virtual worlds and software and stuff like that. But if you say, I'm going to take this toy car and I'm going to get it to line follow on the ground, that's a control problem. And then you're going to hit electrical issues because the battery voltages are going to droop, and then maybe that affects something. You're going to hit friction changes as it goes from carpet to hardwood. You're going to hit all of these problems. And if you want to get to your goal of control, you're going to be motivated to go off and solve those problems. You're going to be motivated to read the data sheets and to learn about I squared C buses and to do all of this stuff that you wouldn't normally do, which I think is, for me, is the way that I get motivated to learn something. Because if somebody says, oh, you're going to need to know mechanics, go study mechanics. It's like, well, that's massive. I don't know where to start. I don't really care because I'm not doing anything with the information. I'll probably forget it as soon as I learn it anyway. And so for me, it has always been being exposed to the troubles and the problems that crop up along the way while I'm trying to do something. And it has almost entirely been while I was at industry. I didn't do this sort of thing in school. And so just over the long course of a career, you just get exposed to more and more things, and you just build up your expertise and your experience, over time.
So one of the other things you touched on in your webinar was creativity in the role that control engineers do. And yeah, I definitely think this is something that isn't no one really, certainly outside of control, no one really thinks of it as being creative. Could you give maybe an example of a problem that you faced that required a particularly innovative or creative solution?
I think it's funny, I don't know, everything is if you're not following a recipe or you're not following, somebody has written a test plan for you and you have to go step by step, then it's inherently creative, right? You have to figure out ways to solve your problem. Even if you are piecing together what other people have already done, you piecing it together is something brand new, and you have unlimited choices in that matter. So my simple answer is that everything is creative in one way or another. One of the things, this is an old story, but it's still something I come back to because it was such a fun example of what you're talking about here, is I was building a CubeSat. This was 20 years ago now. And CubeSats are typically dense and small, which means that they don't slow down very much with the very, very small amount of atmospheric drag in space. You also don't get to choose which orbit you go into. And so you might get placed in a relatively high orbit with very little drag. And the governing bodies of space say you have to be able to deorbit within 25 years. Otherwise, you're not allowed to go. And so people will design in deorbiting mechanisms, things that increase drag so that you can slow down and deorbit within that 25 years so you're not just staying up there indefinitely and crowding out space. Well, CubeSats, especially 20 years ago, were completely unreliable. And so we had a deployment mechanism that increased our drag. And we said, well, how do you get a deployment to happen? Well, you can just send a command and deploy it, right? The thing doesn't work at all. You sent up a brick, let's say, which is highly likely. You sent it up, it doesn't work at all. How do you guarantee that you're going to be able to release this mechanism? Unfortunately, this wasn't my idea, but it was to use UV sensitive fishing line to connect that deployment that is spring loaded. And so we could cut through that fishing line with a heating element and deploy it when we want to. And if everything fails over the course of about a year, just being out in space and getting bombarded with UV, it'll just disintegrate and it'll open up on its own. And then it's like a passive thing. And so you still have control over when to release this thing so you can deploy it, but you can still guarantee to the governing bodies that we're going to be able to meet this requirement of 25 years. And I like that sort of kind of scrappy approach to engineering that comes up maybe even more frequently than you'd expect, which it's not everything's this elegant, nice solution. Sometimes you're just trying to get the job done.
So we've talked about kind of misconceptions that you had going into industry. Have you encountered misunderstandings or misconceptions with people that you're working in industry about the role of a control engineer?
I think the misconceptions come in two flavors. One is that depending on the industry I've worked with, controls is, even though they're working on control problems, they don't have control engineers. They don't think in terms of a control engineer. It's a software engineer who is in some way implementing some feedback that is doing what they want to do. But I think it comes back to the difference between control theory and control engineering. I've never been on the research side, either in academia or in industry. There's research and development in industry. I've always been on the application, the applied part, building products. And we will get new hires in that are expecting to be able to sit down and focus on a problem for months until they get it perfect or until they solve something. And the programs I've been on, you don't have that kind of luxury. And then there's also usually not that need, because you just need to meet a requirement, even if it's like a inelegant solution or if it's still noisy and ugly. If it meets the requirement and does what it needs to do, you move on. You usually have the time. There's this whole engineering project that you need to accomplish. And at first, it can feel a little bit unsatisfying to leave a problem in a state that you're not like fully proud of. But I don't know. I think you kind of get over that relatively quickly when you realize that there's thousands of these little problems and they all have to work together for this system as a whole. And so what you're just trying to do is figure out ways of meeting your requirements along the way. And so it's a little bit maybe different than academia. Again, I've never been in on that side of things. So as an outsider of what I see, of being able to focus on a problem, being able to really dive down deep into it and wander through knowledge to kind of figure out new things and spend that time focused. Whereas most of the problems I've had to work on have been get it to be good enough and then move on to the next one.
Okay, I had a final question in this section. So in each of the seminars you gave, there was time at the end for audience questions. Were there any questions that either you thought, oh, that's a really good question, or that prompted you to give an answer that you think more people could benefit from knowing?
One of the things I forgot when I was a student was how much uncertainty there is in the future, right? What degree should I get? What should I learn? What industry should I go into that I have the best chance? And I got several flavors of the same question, which was, how interchangeable is my skill of being a control engineer across industries? Do I need to pick basically an industry now and stick with it? And I don't know if I have the best sort of fleshed out answer for this, but here's the way I think about it, at least from my experience, is that control theory, like we talked about, is very interchangeable, like the mathematics, understanding how to model a system, understanding how to control that system, understanding how to filter, all of that. It's useful in finance, it's useful in aerospace and defense, it's useful in automotive and robotics and power systems, all of that. You can go anywhere with that. But so much of being a good engineer is understanding your system well enough to know how to model it. What do I need to include? What is important? What isn't important? Can I get away with not capturing these specific dynamics? I don't know. You have to understand the system and the environment that it works in. And at first, you don't have any of that experience. And so early in your career, you can hop around, I think, very easily. And I would personally recommend that, is to try different industries and gain that skill, because it's going to make you a better engineer overall. But it's also, that's when you can do it. For me, most of my experience is in space. I understand the nuances of disturbances in space and how temperature, in space, how it affects things more so than, in an atmosphere. And I've built all of that experience up that I would not be as good. It would take me some time if I moved to the automotive industry now, because I would need to understand automobiles and I need to understand the environment that they work in. And that is a little bit harder to transfer, is just really understanding those industries. So it's not impossible, obviously. It's going to take some ramp up time to understand that sort of thing. But the skills, the hard skills that you learned, completely transferable. And I would recommend, trying out different industries and bringing those experiences around with you and then landing where you feel the most excited.
If you were designing an undergraduate course in control, what would you include to try and reduce some of the misconceptions and kind of better prepare students for working in industry?
Well, can I ask you a question?
Yes.
What was your first controls class like? What was covered?
It was a very short segment of another module that did, I think, introduced differential equations and then state space. I think we did Bode plots and Nyquist diagrams, but no application.
Yeah, I mean, that's similar to mine. So here's the way I think about it is I learned Laplace transforms and transfer functions first. We got introduced into frequency domain methods, which is fantastic, extremely useful. But without understanding that this was a way to model a system. Why would we model a system to begin with? Well, because model-based engineering and model-based design, we've developed a ton of tools that allow us to do things if we have these mathematical representations of our system. You can do it without it. You can go, tune something just by twisting a knob. But modeling is important. And there are tons of ways that we can model it, right? We can model it linearly with transfer functions and state space. We can do nonlinear modeling. We can do all of this stuff depending on what's important. And I didn't understand any of that. I just knew we're going to take an inverted pendulum and turn it into a transfer function. And now from here, think about it mathematically. Let's do a Bode plot. Let's do a Nyquist. Let's wrap a controller around it. And I didn't fully understand where that fit into the grand scheme of things. So I don't know what the requirements are for professors in terms of what they have to teach in their curriculum, but they could teach the exact same thing, or I would, but I would wrap it around this bigger picture of here's what we're trying to do as control engineers. As part of that, we need to model our system because you're going to see later on, we're going to have tons of different tools available if we have a mathematical model. We are going to have to estimate the state of the system. We can do that through measurement. We can do that through estimation, but we have to understand the state of the system. And then we can use that to determine where we want the system to go. And we're going to have to plan, what do we want this thing to do that we're working on? And then we're going to have to say, this is what we want it to do. This is where it is. How do we poke and prod the system in the right places to get it to do that, right? This is the big story. And then we have to be confident in our answer, and we have to be able to do all of that stuff and talk about the big picture and then hone in and say, look, we don't have infinite time. In this class, we're taking this tiny little model of these big models. And then we're going to take state estimation is just going to be a given. We're going to say we're just going to measure it. We're going to know the state. We're going to focus really on the controller itself. And then every time, every module, every class, take a step back and say, here's where we are in the big picture. And this is why we're learning this very specific thing. But it is just a specific thing in the grand scheme of things. And just having that context and that awareness of the little things that I'm learning in this class, how it applies to the big picture, I think would have been helpful. And that's what I would like to see in a class. And then the specific things you cover, whatever the class needs, but just keeping that context in mind when you go through it.
In terms of all the different ways to represent systems, in your experience, is there one that in industry you use more, or does it really depend on the problem?
Absolutely. I mean, you're talking about how we capture a dynamic model, in what form? It is everything and anything. I mean, often a Simulink model, it's a mixed domain complex model, and that's going to be made up of linear models and neural networks that we've trained and ARX models and transfer functions. And so it is everything in anything that makes the most sense for that particular thing that you're trying to do, whether it's model a widget or analyze your system or design on it.
What do you think are the main differences between working in industry versus academia?
Again, as an outsider to academia, here's what I see as the main difference is that in industry, you're given the end goal. You have a finish line. You know what you're trying to accomplish, and you're trying to draw sort of the shortest line from your current state to getting there. And along the way, you're going to encounter errors and problems and challenges, and you're going to have to come up with the creative solutions. You're going to have to learn things to build that system. But you always know where you're going, and you're sort of constrained by the boundaries of the problem, which is in some way, comforting to know that you know where you're going, even if it's frustrating getting there. And my impression of academia is that it's a little bit different, is that, again, you're wandering through what is known and trying to decide where to do research and where to push the boundaries of knowledge. And there's no end goal necessarily. Maybe you might have one, but you can change it as you're going through, as you learn new things and decide new things. And so it feels a little bit less constrained. And so if you have that sort of exploration mentality where it's like, I don't know exactly what I want to accomplish, but I want to, push the bounds of what we know, and I want to be excited about a problem. And when something comes my way, if it seems even cooler, I want to go down that path. I feel like that's what academia is really good at. Whereas on the industry side, it's a little bit more, how do I solve this problem to get back on track, to get back to the end goal that I need to get to?
What advice would you give to a student who likes control theory but isn't sure whether they want to make a career out of it?
I would start by asking what they like about it. Because again, control theory is, it's like solving sort of practical mathematical problems, which you can do in lots of disciplines. And if that's what they enjoy doing, then, it almost doesn't matter whether you're doing control theory or not. There's a lot of really kind of interesting, sort of mathematical problems. For me, control engineering in general is just being able to automate something, whether it's a small, tiny like motor controller or an entire robot that can operate on its own. But to be able to automate something is what I find really exciting, and control theory is a part of that. And I have made sort of a career out of doing very little control theory and still calling myself a control engineer and still being able to go down that automation path. And if that's like your interest, you can do all sorts of things. You can work in any industry. You could be in a lab testing hardware, which might be fun. You could be at a computer writing embedded software, or you could be at a computer analyzing your system, building models, or you could be out in the field helping customers. It's all over the place. And the only way, well, I don't know if it's the only way I know to figure that out is to do it. You can talk to a lot of people. I was convinced I wanted to be an aerodynamicist, like I said. And before that, I wanted to be an astronomer. And I didn't even know controls was a thing until I learned about it. And I was like, oh, this is cool. And then within controls, I didn't even know all sorts of stuff was a thing. A state estimation. I could spend my entire time building a state estimator or whatever it is. And so you have to kind of poke around and do some things and figure it out. And the nice thing about, at least in industry with engineering, is that there's overlap between all of these different disciplines. And you can get into a controls group and realize this isn't quite for me, and easily transition over to another group. Like, for example, we had on one of our spacecraft, we had a lithium ion battery. We needed a state estimation algorithm. We did that with an extended Kalman filter. And the power team hadn't had any experience with an extended Kalman filter. They reached out to myself and another colleague from the controls team to help them build that. And so I feel like you can easily, in industry, in any direction, you can come to controls this way too. You can sort of flow through your career, kind of moving into the direction of the things that you find the most interesting and rewarding. And I personally think controls is a great place to start with that, because it is so interdisciplinary, since your control loops touch all sorts of different aspects of a project.
Are there any factors that you think you need to consider when thinking about a career in control that maybe wouldn't be obvious?
Well, let me say something that I haven't already said. So this might not be the most thing, but communication is exceedingly important. And like, as a student, you're like, again, your head's down, you're focused on your problem. And you don't realize that when you work on a complex system, it's interdisciplinary, like I keep saying. And you're going to create problems for other people. and they're going to create problems for you. And you need to constantly just be able to communicate what is important to you as a control engineer so that you can tell them why what they're doing makes sense or doesn't make sense outside of controls. And you need to be able to understand the needs of the other disciplines. What does the power system care about? And what are their needs? And how are you impacting them? And all of this comes down to just communication. And it's such an important part of, well, of every, discipline in engineering, but specifically in controls, that you rarely get the luxury of just sitting down, heads down, ignoring everybody else and working on your problem. And communication doesn't have to be verbal. It could be through requirements. It could be through writing down, what your system does, describing it. It could be through presentations, all sorts of things. It's just having that kind of, open mind that we're going to work as a team here to solve these problems. And that requires just good communication between people. And that's, not something I prepared for or really learned to do when I was a student.
Finishing off the section about advice on students, is there any other advice that you would give that you haven't already mentioned?
I don't know. I would just encourage people to experience as much as they can, whether they're students or whether they're in industry, and jump jobs to a complete, even on the same project, but take on a smaller project that you might not understand or feel confident in. Because for me, again, that's how I get motivated to learn something new. And every time you learn something new, there's a way to bring that back into your job. You can use that experience, even if your new thing is you want to go off and learn how to do art. You are now better prepared to make presentations, technical presentations. If you want to go off and learn music, it's just every experience you have, I feel like makes you a better engineer overall, because you got to pull all of those experiences together and you can find a way to bring them into the problems that you're trying to solve.
Okay, kind of changing track a bit. So I'm curious as to your thoughts on kind of changing landscape of control. Do you think things have changed since you started working in terms of the transition from degree to industry?
I think so. Aerospace, I feel like, was kind of the pioneers of model-based control, in the 50s and the 60s. And then it was well established by the time I started, and we were using Simulink and all sorts of models to do all that stuff. And I found that that's not the case in other industries. Other industries over the 20 years that I've been working have really started to ramp up their adoption of model-based design and understanding the needs for control engineers. And then over time, we've started now relying more on virtualization and modeling more and more. We have more tools available to us, and we're doing possibly more on that aspect than we are with physical testing, and testing in the field. And I feel like that's going to probably continue, especially with this push with AI and generative AI, which is allowing us to kind of, in a way, abstract some of the lower level engineering that we were doing, like the specific code writing, abstracting away into more understanding your system in a way that you can write it out in plain English, and then what gets generated is that lower level code. Almost like how when you write in computer code, it then gets translated into a binary file, in that sort of sense. And because of that, control engineers are now becoming closer to systems engineers, in my mind. And I think that's where it's going to go into the future, where you need to have awareness of embedded code. You need to have an awareness of how to model a lot of different components in your system. And you need to have an awareness of how all of this kind of plays with each other. And so having that sort of broad knowledge, that systems engineering approach to controls, I think that's sort of the trend that I see anyway, as opposed to really getting down into the nitty gritty of specific algorithms, at least across the board. People are still going to have to get into the nitty gritty of algorithms, but a lot of control engineers, I think, are going to be at more the system level and continue on going into the future. But I will follow that up with say that I'm extremely bad at predicting the future. So many of the different things that we're doing now, I didn't even see coming, and I probably would have said wasn't coming. So keep that in mind whenever I make any sort of prediction.
I mean, because the next question I was going to ask is, do you think there are any skills control engineers should be aiming to develop now to prepare them for the next decade?
I think it's the same skills as always, which is problem solving, being able to learn new things, and being able to sift through whether that information that you just read or learned about is going to be helpful for your problem. Discarding it quickly, moving on to the next thing, and figuring out a way to solve a problem. And it's just the tools that we use and the knowledge that we have are changing. But that problem solving, I don't think goes away. And it's extremely important because, again, you have that end goal in industry and you're just hitting snag after snag after snag. And these are problems that you've never considered, never thought about, never trained for. And so you're just finding ways to solve those problems, whether that's Gen AI or other AI techniques that are helping you solve those problems, or you're going back to the literature and you're, trying to implement something that's more of a classical approach. Almost doesn't matter, right? You're just trying to figure out how to get past those problems.
So I have a bunch of extra questions to ask you at the end. So the first one are related to your videos, and then there's a few more general ones later. Do you think that the field of control as a whole is doing a good job of kind of telling its story to the world? So I know there's a lot of hype at the minute about AI, but maybe people don't know as much about control, and how do we get people more excited about control?
I like that question because you said to the world. I think we do a really good job of telling our story to ourselves. It's pretty much what I do, and it's what other content creators do and a lot of professors do. We are really good at telling controls to each other. The thing I think we're not good at, and I've tried and I'm bad at it, is telling it generically to the world, making it interesting to just curious people. I think about the fact that physics is so popular that you could go to a random person on the street and I think they would have more familiarity with Schrodinger's uncertainty principle, which I think has zero bearing on their life, than they do with the concept of what feedback is, which I think has a huge amount of impact on their life. Even just understanding the idea of feedback, you can apply it to all sorts of real world problems of yourself, of how do I accomplish my goal? And you can think of it in terms of where am I now? And what control do I have over my life? And how do I measure it? And I just think that's really, really sad because we have such interesting topics in controls. And I don't think we've done a good job because AI has sort of usurped that. And people think now in terms of, oh, AI is this, AI is that. And it's well, adaptive control has been doing a lot of this stuff for a really long time. How come we didn't get all of that excitement to the general public, I would love to see a large YouTube channel like a Veritasium or a Smarter Every Day or Mark Rober or something like that popularize some of the basic concepts within controls. And they don't even necessarily have, I'd like them to say controls because I want people to be associated with it. But I think it's, like I said, it's interesting, it's relevant to people, and I think curious people, even non-engineers, could benefit from understanding that. And I think the field as a whole, our field, could benefit from that sort of general awareness of what it is and why it's important.
Okay, in terms of your YouTube, were there any topics that you thought would be simple to explain but turned out to be really difficult?
So there's two flavors of videos that I find really hard. And the first is an overview of X, whatever it is. It's I get asked, can you make an overview of all of control theory, in 10 minutes? And you're of course you can do it, but you necessarily have to leave things out. And you have to simplify stuff. And it's how do you do that without misconstruing what it is and without leaving out an entire section? And so people don't consider that. And those types of videos are really hard. I think they're useful, but I have the hardest time making a big overview video as opposed to, what is post graph optimization? It's okay, well, that I can spend 10 minutes on and, do a pretty good job. The other videos that I find difficult are ones that I can't figure out a good visual interpretation of, I have to rely on the mathematics of the problem, because writing out a series of equations in a video is deeply unsatisfying to me. And then when I watch a video that just has a string of mathematics in it, it's like, oh, this could have been a paper. And I want to sit there and I want to dwell on it for a little bit and understand it. In a video, I want to make use of that media to move things and to visualize stuff and to spin things around and to be able to get an intuitive understanding of what's happening. And so to that end, my video on the algebraic Riccati equation was really difficult, because I'm sure there's a visual explanation out there that I just could not figure out or find. So if anybody listening, if they have one, please send it to me. But that one ended up being a more mathematical explanation, and therefore, in my mind, just not as satisfying as other types of videos.
If you could collaborate with any other kind of YouTuber or educator, either in control or kind of science and engineering more broadly, who would it be?
It'd be the folks that I just said. It would be those large multi-million channel or like subscriber channels that have an audience of curious people, because I would love to use their platform and their enthusiasm for just knowledge to help them tell a really like fun and compelling story, to sort of reach that general audience. Within controls, I mean, there's all sorts, I'm not going to name names, but there's all sorts of people I would love to collaborate with. Everybody here, we're at the CDC 2025 right now. Everybody I talk to, they all have interesting stories. They're all doing interesting research. And it's just like, I would love to be able to sit down and help you tell that story, because it's all fantastic. But practically, I think trying to find a big channel to do that mass outreach to a lot of people would be really fun.
Have you tried reaching out to any of those channels?
I have not.
Maybe you should.
I might. I should. I probably should. I just, I feel like I want to come up with a good story first and then pitch it to them. And I haven't spent that time doing it. But maybe I will now.
Are there any videos that you'd like to make that you either haven't been able to or haven't gone around to, or kind of topics that you'd like to learn and discuss more about?
You know what? Some of my favorite engineering channels and engineering companies in general are the ones that take the audience along with the design process. Like, I think early SpaceX did this really well. And I was in space, and space, you don't tell anybody anything that you're doing, because you need to make sure you have to project that everything is going perfectly well so that you can keep getting funding. And then you make sure then you do a test in secret. And if it works, then you tell the world, like, we did this test and it was amazing. And SpaceX said, we're going to bring you along for the ride. We're going to show you all of our flaws, and you're going to become invested in our success. And when we fail, you're not going to say, what a waste of money, or you guys don't know what you're doing. You're going to say, oh, you're going to get it next time, and next time you're going to do a little bit better. So that's a long way of saying what I'd like to do on YouTube is come up with projects where I can tell the story of how they're like designing it real time. Because right now I test everything ahead of time. Even when I do the wrong thing in a video, that's all planned, right? To tell a story. And I like the idea of showing, the engineering process. We talked about hitting all of those snags along the way as you get to your final product, and show how, me or somebody else would go about solving that. Getting feedback from the audience real time, or not real time, but after one video, and say, next week I'm going to try this other thing. And I would always wanted to do that with controls, because it would show how much more than control theory getting something to work is, and how fun it is to encounter a problem that you have no idea what's going on at first, and then just start deep diving into it and troubleshooting it and figuring out what the issue is, and then getting past it, and then moving on, and then hitting the next snag. And kind of telling that story with an audience, I think, would be real fun.
What's your favorite video you've made? Do you have a favorite? I
do not. I do not have a favorite. My current favorite, my current one I really like, we'll say, is when I have never heard of a topic and I'm asked to make a video, and I research it a bunch. People tell me things about it, and it just turns out to be amazing. And it's like, how did I not know this was a thing? And then I'm excited because I learned a bunch, and I'm excited to show people, check out this thing you might not have heard about. And the latest one just posted in November of 2025 was on formal verification methods for neural networks. So it's talking about deep poly and the crown algorithms, which again, I came in not knowing anything about. And the idea behind it is that if you have a neural network with a series of inputs, instead of sending in one input state, one data point through the neural network and then seeing whether it classified it correctly or not, you can send in a constrained input, like a bounded input, either, with inequalities, or there's different ways of doing it. And then you're sending that sort of like area into the neural network, these constraints. And then as you get to activation layers, you might add more constraints to account for that. And then what comes out is a series of constraints for the output. And so you say, as long as your input is constrained within this, within this area, you can guarantee that the output is going to be in this area. And if that area is fully contained within the classification region that you care about, you can now guarantee that even in the presence of noise, this neural network is going to perform. And it's not something I'd ever thought about, never once. And I loved it. I loved the whole process of reading the papers and learning about it and animating it and then getting it out into the world and hopefully, exposing it to more people also.
Yeah, I think my favorite podcast episodes to make are ones where I knew nothing about a topic and it's like, oh wow, this field exists. Okay, I've got some kind of quick fire questions at the end. So you said that you basically just worked in aerospace engineering throughout your career. Are there any other areas of control that you would like to or would have liked to have worked in?
It turns out the thing I'm most interested in is autonomous vehicles in remote settings. And so space fit the bill. I would love to work underwater. I'd love to work in caves, maybe disaster relief, wherever it is that people can't go and you need to go and do science or you need to go and do exploration.
What is it about that you think kind of captures your imagination?
It is the idea of not being able to physically go somewhere and still know so much about that spot, so much about it. Know what the surface of the moon looks like, know what an asteroid looks like, know what's in the deepest areas of the ocean where you don't want to send a person or it's not possible to be able to explore. I don't know, it sort of scratches that like childhood itch of exploration and advancing science that I find really fun. Like, I like the idea of like autonomous driving, and I think they're solving really fun problems. But for me, it's not quite the same as building something that can go where people can't go.
So, we talked a lot about your advice to current students. What's the best piece of advice you've ever received?
The best advice, I think, this is going to be a roundabout answer. I'm going to make it quick. When I was an intern, I just started at Boeing, and my manager was sort of parading me around to all of the people in the group. They were all control engineers, and they were just saying, hello, hello, hello. And then one person who was very, very experienced, they said, I'm going to tell you everything you need to know about control engineering. And I was very excited. And he said, don't divide by zero. And I thought, what does that mean? And now, 20 years later, I still don't know what that means exactly. Was it talking about just like with transfer functions and trying to avoid unstable regions with divide by zero? Is he talking about just metaphorically, don't ever, blow up, emotionally or anything like that? No idea. And I thought, you know what? That was useless. And I don't want to give useless advice to people in any way that makes me feel like I know something that they don't know. And I feel like that has sort of guided the way that I do explanations and guided the way that I like to teach, which is trying to make it accessible and trying to talk around concepts that may have a specific name, say that name, and then talk about what that means and what, try to talk to the audience or try to talk to whoever I'm talking to, because that still bothers me that he said that, and I have no idea what he meant.
What is your favorite part of your job?
My current job? Or
Yes.
control engineering job?
Both.
My current job is that I get to learn new things all the time, and I get to apply sort of my artistic creativity to storytelling, and I get to help people appreciate sort of the joys of engineering and the joys of controls, and that makes me happy. that I can sort of share this excitement with a lot of people. When I was in industry, I did a little bit of that internally, but the thing that I found the most exciting was solving a problem. I loved it. I mean, like, it's frustrating as anything when you don't know the answer and you're asking people for help and you're searching the internet and you're reading papers, and then you find the answer and you get to move past it and you're just like, wow, that is no longer a problem that I have to deal with, and I'll know what to do next time. And so I really enjoyed solving problems, and now today I really enjoy talking with people and motivating them and getting them excited.
Final question. Who's your role model within control engineering?
My role models, I would say I had lots of people who have influenced me. Everybody I've ever sort of interacted with for sure has influenced me. The two that I think has shaped me in hindsight more than any others is that when I was an intern and an early engineer, we had a very experienced engineer, very busy, very important. His name was Michael Santina, and he spent extra time making sure that the interns and the early career engineers knew what was going on and what was happening. And he ran a class every week that we could go to, and he would answer questions, and he would solve problems on the board and see how we were doing. And I just thought it was so cool that this person was taking their time to guide us and to make sure that we were, entering into industry on the right foot when he had so much other stuff going on and so many more important things. And then much later, 10 years later, before I started my YouTube channel, there's another engineer I sat next to. His name was Monty Evans, and he was sort of one of the important control engineers for the 777, the Boeing 777 aircraft for the primary flight controls. And he was the one who taught me a lot of the intuition behind frequency domain methods. Because when I worked in space, it was almost all time domain stuff. And I got to the aircraft side of things, and I felt silly that I did not know frequency domain very well. And he spent a lot of time explaining it intuitively to me in a way that I carried a lot of those types of explanations into my early videos. And it was sort of the genesis for me wanting to tell those stories.
Thank you so much for the interview.
Thanks for having me. It was a pleasure.
So, in summary, the theoretical side of control is only a small part of a control engineer's job, which can encompass tasks such as modelling, interfacing sensors and actuators, testing and system integration. Control engineering intersects with all other aspects of the system, so it's important to be able to communicate well with engineers working in different disciplines. Industry work is often focused on a specific goal and is focused more on meeting requirements and dealing with trade-offs than achieving an optimal solution. The skills of a control engineer are highly transferable, and it can often be beneficial to explore a range of industries early on in a career. And we as a community are currently not doing a great job of explaining the value of controls to the general public, despite the fact that feedback and regulation have a massive impact on our everyday lives. I really hope you've enjoyed this episode. If you would like to hear more podcast content from Brian, he was on the In Control podcast a few years back, and there's not a huge amount of overlap with this episode, so I would definitely recommend giving it a listen. As always, if you'd like to get in touch, you can connect with me or the podcast on LinkedIn. The next episode will be released on the 1st of May. I'm actually editing this current episode together way ahead of time, so I'm not entirely sure what next month's episode will be. So I guess it'll be a surprise for us both. But in the meantime, I hope you have a wonderful month.